This is the second part of the algorithm series, and in this video I'm going to talk about the selection sort algorithm. Selection sort is basically just an improved version of bubble sort, and the main difference is after the comparison we will not immediately start to swap the values, but instead we will save the position of the highest or lowest value in a variable, and then after going through the list we will start to sort the data. So I will just start the algorithm now, and on the left hand side we can see the most important variables. Here's our list, and we will sort this list so that it starts in the end this list will start with the lowest value and end with the highest value. So it will start with 1 and end with 5. And the first step, we need to save the value of variable I and index. And then later we will update index, and index it will always point to the lowest value in the list. And j will start now with a value of I plus 1, so j will be 1. And here's a comparison. If data j is smaller than data index, then we will execute this block. Data j points now to the value 4, and data index points to the value 3, so index is 3, j is 1, and the 3 data index is not bigger or not higher than the value 4 data j, and that means we will just keep counting and we will not jump into this block. Now data j goes up to 2, holds the value 2, data j points now to the value 2, 0 element, first element, second element, so data j points to 2, and data index is still pointing to 3, and we can see already that the 3 is higher than the 2, and that means that we will jump into this block, and then we will save the position of the lower value from this comparison. So index will hold now the value, or not the value, but the position 2. Okay, in this case it would also be the value, but yeah, it points to the position in the list. And index holds now the value 2, j goes up to 3, and data j points to the third value in the list, so 0, 1, 2, 3. Data j will point to the 5, and data index points to the value 2. So that means data index is not higher than data j, and because of that we will just keep counting, and j goes up again, so it holds value 4, and data j will then point to this value, so 0, 1, 2, 3, 4. Data j holds the value 1, and data index points to the second element in the list, 0, 1, 2. Data index is 2, and we can see already that 2 is higher than 1, and because of that this block will get executed, and then we will save the position of the lower value. In this case it's 1. And then we can start to sort the data. If index is not equal I, that is, we use this because we don't need to format the list when there are double entries, for example. I could have something like this. So that would make sense to start the data if index points to the same position like variable I. It would make that would make no sense to sort the data then. And because of that, yeah, we use this comparison. And now we will save the data from data I and t. So data I holds the value 3, variable t will hold the value 3. And so what we're doing here is we are basically just swapping the values between data I and data index, and data I will point now to what will hold the data of data index. And here we can see that is 1. And now we need to restore the data that we have saved here in T. We need to move this data now to index, and index will then hold, or data index will then hold the value 3. And as we can see, the list is still not formatted, so that means there are still a couple of iterations that we need to do. So the current list holds the values 1, 4, 2, 5, 3. And again, we will save the value of variable I in index. So index will hold the value 1. And j will hold the value 1 again. Sorry, 2. And then we have the conversion. Data index points to the value 4, and data j points to the value 2. And we can see already data 4, data index is a higher value. Then we will jump into this block and we will save the position. Data j would point then to this value. So index will get the value 2. And then we can keep counting. Data index points to the value 2, and data j points to the value 5. And that means, yeah, we will not jump into this block, so we can just keep counting. And data j holds the value 3, data index holds the value 2, and again we will not jump into this block, and we keep counting. So that was the second iteration, and then we can start to sort the values again. Data I will hold the value 4, so the variable t will hold the value 4. And then we start to swap the values again, and data I, it will get the value 2. And data index, it will get the value 4. And now we can see our new list: 1, 2, 4, 5, 3. It's still not sorted, so we need to keep counting. And again, I goes to index, and you can see already data index is again it is holding the lower value. Data j is higher, so that means we will not execute this block, and we just keep counting. Data index holds the value 4, and 4 is bigger than 3, so that means we will go to this block. And j holds the value 4, so index will point to the to position 4 in the list. And we can sort the data again. Data I holds the value 4, so the 4 goes to t. And data index holds the value 3, and the 3 goes to data I, so data I will be 3. And then we can restore the data. T holds the value of 4, so the 4 goes to data index. And here we can see our list. 1, 2, 3, 5, 4. We're pretty close now. And we need another iteration. And yeah, again, move I to index. And data index is holding now the highest value. So data index is higher than data j, and that means we will jump into this block again. And then we can sort the data. Data I goes to t, t will get the value 5, and data I will get the value of data index, so data I will be 4, and data index will get the value from t, that's a 5. And here we can see our list, and the list is now sorted. And yeah, that's basically the whole logic. And here's a version that is a little bit more Pythonic. Of course, this is easier to swap the data. And yeah, that's everything for now.